Understand? So, good afternoon. My name is Madan Karthikeyan. I am working as a tech analyst in Object Automation and Software Systems Private Limited. So, today I welcome all the participants for this tech meet. So, this tech meet it happens every 2 weeks. So, once in 2 weeks we have a tech meet. So, what we do, we invite guests from various fields. Today, our speaker is Dr. Sri Sharmila. She after the my session, she will talk about few things. So, I welcome all the participants for this tech meet. Before I start, I'm going to give a brief introduction about what object adoption does. So we have a professor with us. I'm going to talk about what we do and what are the things we do for colleges and universities. So if you can see in the first slide, so we have two logos. One is Open Power, the other one is UC San Diego. So UC San Diego stands for University of California, San Diego. So University of California has many campuses in the US. San Diego is one such campus. We have tied with San Diego campus, whereas we send students for the admission. So from here, students get placed for universities for PG courses. Okay. So what is Open Power? So Open Power is a foundation. It is from IBM. So it is basically an open technical community. So what we can do with this? So what we can do? There is a power architecture. The power architecture is nothing but a group of family of clusters developed by IBM. So people who are members of this organization and people who are members of this Open Source Foundation organizations, they benefit by having they are given access to open hardware and software. So you can see here they are given access to open hardware, designs, firmware, tools, and global community. So what are the three main things you can do? So by being an individual member or being an organization being a member of this Open Source Foundation, what are things you can benefit or what are things you can do? The first thing is maybe people who are from ECE, EEE, they may get benefited from this. So like for example, chip design. So all these things are from using this IBM Open Source Foundation. A lot of people are doing. So for example, we can build custom hardware systems with OpenICA. ISA is nothing but instruction architecture. So we can also leverage the open power instruction architecture to design custom CPUs. So using the IBM, using this instruction architecture, what we can do, we can design custom CPUs, central processing units. We can build system on chips. We can also design the entire hardware platforms. Using this, I'm being a member of IBM Open Source Foundation. So these are the other things you can do. So you can work on projects like Microwatt. So Microwatt is one open source code. So using this, we can create some projects. So you can also build on SOC. SOC is the system on chip. So these are ideal for companies and researchers who want control on silicon and firmware stacks. So these are things you can do. So basically, what does object automation does? So mainly we do research, solution development, and establishing centers of excellence in various universities and colleges. So we have a development center in India. Our office is headquartered in California, United States. So these are the main things we do in OA. So we started in 1996 by doing Unix projects, and we are doing from the year 1999. We are concentrating on high performance computing. From since 2011, we are doing artificial intelligence works, and from 2017, we are working on chip design. So as I said, we have an office in Chennai and California. So we focus mainly on quality, technology solutions, and client relationships. So these are the 5 verticals you can see. I'll just speak about the academia. So we regularly set up center of excellence. So what do you mean by center of excellence? For many universities and colleges, they require software and hardware. So further, to fulfill that curriculum process. So what we do on behalf of the college, we go to the various vendors, procure the software and hardware, and we set up a center of excellence. So for example, our boss was an employee of IBM, so we used to set up a lot of IBM servers in various universities and colleges. And we also regularly conduct faculty development programs. So what is FDP? So for example, for faculty members from various colleges, they may not be aware of data strengths. So we bring people from on-site or people from India also to conduct seminars, workshops, so that the faculty members are benefited by their experience. Like for example, from industry people, we bring industry people from various technology, real-time experience or real-time experience. They will be sharing their experience to the faculty members. That way, they will be sharing their experience to the students. So we so these are three things we do. These are three main things we do: onshore, offshore development, research solutions, and technology enablement. So what do you do in technology enablement? So as part of technology enablement and center of excellence in universities and colleges, we conduct technical courses. See, we conduct in person as well as on campus. So for example, students come to our office also. We also go to the campus. We conduct courses tailored to the universities, colleges needs. So regularly we conduct internship. So that is most of the students are engineering students. So as part of the university mandate, as per the university regulation, so a student has to do some internship. Whether it's a Food India 30 day, people students come here, when we go to the colleges, we conduct full-time internship. That way they are getting some real-time experience. So we also conduct technical workshops. For example, last year we conducted in SRM Navapuram campus a global AI festival. A year before that, we conducted in Saira Global AI Festival. Okay. So we regularly conduct global AI chip design conference in various colleges and universities. So as I discussed earlier, we procure our own software and set up it university and colleges. So we have highly skilled employees on these platforms. We have artificial intelligence resources, high performance computing resources, as well as chip design and verification skilled professionals. So what are they? So they are working on real-time projects. So these are our international key collaborators. So you can see University of Oregon. So we have a tie-up with University of Oregon, so whereas students can access the server in University of Oregon. So for example, in chip design, where you require a lot of hardware infrastructure. For example, deep learning calls and all, you require GPUs. So in server, you can access the servers in University of Oregon. So we are providing access to students to access the server in University of Oregon. So we also tied up with Ohio State University. So these are the universities in US, University of Wisconsin. So these are our key collaborators and institutions. So we have signed up memorandum of understanding with these colleges. So if you can see VIT, Shastra, NAE, SRM, Sairam, JNUA. So not only we are signed up a memorandum of understanding with colleges and universities in Tamil Nadu. We are signed up with other states also. For example, NIE, National Institute of Engineering, it is located in Mysore. So it is one of the oldest engineering colleges. We are set up an IBM Center of Excellence in NIE. Similarly, if you can see JNPA, Jawaharlal Nehru Technology University, Anantapur, we recently conducted FDP on machine learning and deep learning. So, one more thing you cover is IBM Career Education Program. So, what does IBM Career Education Program means? So, what does it do means? It bridges the gap. So, there is a gap between the academia needs and the industry. So, to fulfill this gap, we are conducting this IBM Career Education Program. So, that way, what is happening is, so what is how the students get benefit is, so whatever is academia is needing, whatever the
So I hope you guys like definitely there are people are there, and you guys like definitely will put some effort and see how you want to innovate things on the platform whatever we are creating. And we do have a very strong tie-up with University of Oregon, where we have $1 million worth of system. $1 million is nothing but 8 crores worth of systems, hardware systems available, where people can go and click and and do the programming from the the chip to the the solution, and that kind of access we have to, and probably like my team members, Anand, and Kripaladi and where are they? Okay, Karthik will talk about some of the stuff whatever we are doing with the University of Oregon too. So that will help you to really see how you want to set up that kind of a center of excellence at your institute or at your organization. That is what we want to educate here, and as part of the tech meet, and certainly every meet you will get to know something new, and which you can go and inculcate. I mean, here you can get inculcated and then go and innovate in your institute or in your organization. Okay, so feel free to ask questions. Certainly we'll help you out, and also we can do a follow up things. The follow up calls, we can have a collaboration, we can sign up a MOU, all the stuff we can do too. Okay, and now with this, I'd like to invite Sharma ma'am from Anna University in Hindi campus to talk about our perspective on AI and whatever collaboration we have been having and how we want to take it to the the future world with Anna University. Yeah, one more thing, Anna University is very famous in India, one of the best universities in India too, and it's not like
Thank you, sir.
yeah, yeah, no, no. Whatever I have seen, whatever I have been working with. Yeah, yeah, please. Go ahead. Go ahead. Talk about other. He wants to share Professor Sharmila's experience.
Good evening all. I welcome
Yes,
Dr.
sir.
Sri Sharmila. She's our distinguished speaker for the Techmeet today. So I'll give her a brief, I'll give her a brief introduction about her. So Dr. Sri Sharmila is an associate professor at the College of Engineering, Guindy, Anna University. She is the chair of IEEE Women in Engineering. She is Madras section. She is also the vice chair of Education Activities Committee. So here she will be exploring the role and necessity of technology enhancing traditional medicine. Thank you, ma'am. Welcome.
Yeah, madam, small appreciation, Usually, the people do it at the end of the session, but here we are doing so. This is the latest stuff we did.
Thank you so much, sir.
And, yeah. Madam, Kirtan, come here, you can do the salve for her. Thank you, madam. Come over here.
Thank you, sir. Thank you
Happy to
for
collaborate
inviting
more
me.
and more. Yeah, sure.
Before setting, thank you, sir, inviting me to this Techmeet and discussing my research area. Actually, I'm currently doing this work, so I'm going to discuss the same with you. And sir, when you introduce one small correction, I'm the past chair of Human and Engineering Madras section. So now I'm the Executive member of IEEE Madras section, one of the executive member of IEEE Madras section. So previously, here in Anna University, I joined between 2023. Previously, I was with, I hope you have known about SSN College of Engineering. So 18 years I worked at SSN College of Engineering in various roles. So my last role at SSN was associate professor. So I'm continuing associate professor role at CUG, Computer Science and Engineering. And then IEEE is only connecting myself with Ganesan sir. So I mean, we can say IEEE. Why IEEE? Is there any? I mean, generally students used to say the volunteering as well as the networking. For me too, the volunteering as well as the networking helping me my technical exploration in various fields in my research area as well as to I mean engage myself in various leadership roles. So definitely, I mean, as I hope you are also a student. At your institution, you might have the IEEE student branches, so volunteer yourself as one of the student member and other society members too. So, here, I mean, currently with the doctor's help, I'm doing this research in the past 1 year. And I just want to deliver this to this particular technique. The reason is, since we are in Tamil Nadu, we should identify what is our traditional thing. And as I said, AI is in all the areas. So how can we use AI technologies in at least the traditional medicine? So I want to acknowledge Dr. Shailaja as well as Sukundar. So they are helping me to collect the data as well as the validating our work in their clinical studies. And of course, Anna University. So without the university resources, it would not be possible to do this research. And I thank Object Automation for inviting me to deliver my research content to this technique. So, I mean, sir, shall I take one more?
Oh, yeah.
Okay, I try to wind up. I hope this. Yeah, so yeah, it's in healthcare. So people generally talk about the allopathy as well as I mean the government is giving more importance in Ayush. So one of the traditional medicine here is I'm going to talk about the Siddha. So in Siddha, suppose if you go to any Siddha doctors, they used to hold your hand and hold your wrist and check some signals, some pulse variations in your wrist. So they can identify some rhythmic volume flow in the pulse rate. So generally we call that as that is the Vada Pitta Kabam. And that is one way of identifying the symptoms in the body. Another one way is when they analyze our blood flow in the wrist, they used to talk about our body conditions. So, how are you? Do you have any problem in your body? Which area? So, have any? We used to say our problems. When somebody asks something about ourselves, and that to the doctors, we used to say these are all the problems. Yes, with respect to some symptoms. So, yeah. So here, in this particular research work, we have collected the data from some traditional books, which was written by the Siddhas as well as some poets. I mean, we could study those things in Tamil. Tamil. So it was written by the Agastya, Tirumula, so the poets, and we have collected some symptoms. Okay, with respect to this Vada Pitta Kapam as well as the combination of Vada Pittam and Kapam. So totally we have 9 types of body types. So Vada Pittam Kapam and their combinations. So combinations are 6. Vada Pitta Kapam individually 3. So totally 9 body types. And we collected which is important there. This one.
Adam.
So we have collected this much symptoms with respect to the Nadi type in the literature. So this is actually limited. We need to collect more data to do this research. So generally, when as an engineering perspective, suppose you are going to do any project, we ask you to frame architecture diagram. So the first one is the data collection, then we have to do the pre-processing as well as the feature extraction, then do the modeling. Since here the data is very limited, we have done machine learning algorithms to predict those. We will see one by one.
Yeah, one thing I just wanted to add here is since you're showing something there. Anyway, how many of you know sugar monitoring system? Okay, definitely your dad or will be using it or whatever. Anyway, I have a connected system on my body. This like a kind of system here. I don't want to show it here, but anyway, here there is a sensor attached to my body where It basically takes the blood from the body every not every second, but every probably like 3 to 4 minutes, and then send that data to my app. And what happens? It immediately tells me the sugar level. So that is what Madam also demonstrated here. With the Siddha, with the this is for sugar purpose, but there are multiple organs are there in the body actually, basically. So all these organs will be maintained through the app going forward, and that's how AI will help you a lot. And HR, you said about it, right? Similar to that here, healthcare system, doctors are going to be replaced? Certainly not, but the doctors have to learn about AI and the features, the semiconductor, the sensors, all this stuff they have to learn. Then they can get adapted and they can go with their career too. So yeah, I think this is very, very
Yes, sir.
great. Everyone should learn about it and start working on this.
So our first idea is to collect the data. So from the data, how the doctors analyze our body types. So here our body types are Vata, Pitta, and Kapha, and their combinations. So initially we talked with the doctors, and they have given they have analyze these symptoms from the literature. So that was 4 line poems, and suppose when we study the Tamil poems, even in the 9th or 10th standard, it is very difficult to understand the concepts delivered by the poet. So the same thing happened for us also, but the doctors, they have understood what was written, and they have given the uh, here the symptoms. Okay, these are all the symptoms as well as the region of the body. So the region, they have divided this into actually the whole body, then head to supranoster, and supranoster to umbilicus, umbilicus to anus, then limbs, as limbs and the whole body. So in that way, they have given the data in Tamil. Okay, we have to convert that into. So we have converted the data into English. I hope you have known Tamil. Just I'm reading few. So first part head to supranostril. So it is nothing but the காதடைப்பு, that is ear drop. Then தாகம், thirst. This is நாக்கு சொல்லுவோம் இல்லையா, வறண்டு போறது. So xerostomia and கண் கடுத்து கண்ணீர் வடி. This was given in the poem. Okay, so we have to convert that into the corresponding language. So here it is English. So we have planned to convert into other regional languages also. So accordingly, we have generated the data for all the regions, and here we have collected the data from around 19 books as of now. But so many poets written in different way. Some overlap also available. So this was the symptoms for Vata, and again I have given few here. So this is for the Pitta Vata. And so once we collect the data, so here the data as of now it's private. Since we have collected the data, we are keeping, since we are doing the research on it. Next, we have done the pre-processing. So this is the NLP process. So in the NLP, what we have done is we have corrected. Suppose if I type any misspelling, here also they have done the research. The previous technique, I forgot the name, but they have showed what they have done for the pre-processing as well as the feature extraction. The same thing happened here also. And here we have used the TF-IDF. Since the data is in the natural form, that is in English, we have converted that into the vector form by using the TF-IDF. That why TF-IDF? It can be easy for assigning some weight for the data. So in the TF-IDF, we have here the data mainly for the symptom data as well as the regional data. So we are calculating the term frequency for the symptom as well as the term frequency for the region in some mathematical way. So the term frequency, that is the TF-ID transformation for the symptom generally denote this as TF of T comma D, which is nothing but the term frequency of the symptom T, which is in the document T, as well as the inverse document frequency. So how we calculate the TF of, that is the term frequency for the symptom is F of T comma D, that is the count of symptom, particular symptom T appearing in a particular document, which is divided by the summation of the count of the symptom appearing in the patient record. So, like using this, we can calculate the inverse document frequency, which is nothing but log of n by 1 plus nt. What is n here is the total number of records of the patient, and nt here is the number of records containing the particular symptom. So, like this, we can also calculate the TF-IDF for the region. So, once we calculate this, what happened here is, since my our assumption and how are we starting is, this symptom data as well as the region is going to play a major role when to identify the body type. So we just combine both symptom data as well as the region data. So which is representing the target variable. So target na output. So output here is the 9 body type that can be calculated. Next, generally in the machine learning algorithm. So here, just to see the input. Yes. So when we collect the data for bottom, we have, it is possible by us to collect 93 symptoms for the particular body type. But even just to see this Kababadam and the Kabapitham, I mean, only we have 38 or the 43 data. So this is nothing but the class imbalance. So it may bias to produce the output. So we have to address this problem. So we have, I mean here what we have used is the mode as well as the ROS to balance this input. These algorithms can generate the data synthetically to balance the symptoms data. So again, I mean, as of now, we have just used the machine learning algorithms like this, k-nearest neighbors, logistic regression, support vector mission, as well as the XGBoost. So where we can apply these machine learning algorithm, and the application for the machine learning algorithm also has been given. So finally, when we see the output, okay, suppose recently, with respect to the region umbilicus to anus, that says the body belongs to Pitta. So if it is Pitta, I mean, if we can able to identify the body type as Pittam or Pitta Badam, the dietary plan automatically can be produced. So accordingly, we can maintain our body in a healthy way. So that is the ultimate plan. So in the machine learning algorithm, what we receive the accuracy as of now here is XGBoost gave 74%. So compared to other algorithms, reason here is it supports the parallelism as well as that handles the missing data. So our data is a natural language data. So I mean something happened on it and it gave a good result. So this is the preliminary work what we can start at. So next we think how can we apply our knowledge since most of the all the algorithms are already available. We just have chosen and apply on our data. We have received this result. So next what we thought is okay. So how can we handle this? How can we produce a better result using this data? As of now, what I have shown is the given data. So for this, what are all the different ways to produce the result? So what we have done is, I didn't have the particular architecture. We have applied the NLP For the word embeddings, we have used the glove model for the word embeddings, and to address the symptom with respect to the region, we have used the fuzzy mapping, and occurrence of the particular count of the symptoms. I have used the inverse frequency mapping. So that is our contribution on it. So again, in the previous model, when I give a particular symptom, say I have given a single symptom with respect to the region that produce the body type. Instead, if I give a lot of symptoms, okay. So first, the system asks. So this is our application. So in the first task, I must prove the body, the whole body. What since when we go to the doctor, what we immediately say, which is the major problem. Yes. So the whole, I mean, throughout the body, what are the problems? So here I have given that is the sorry. Yeah. So aching or pricking pain as well as the fever. Another symptom is the acute pain. So this is happen in the whole the body. Then next, from head to supranostril. Here I have given burning of eyes as well as the blurred vision. Then from supranostril to umbilicus, that is burning sensation in the chest and burning stomach. So, I didn't give any symptom with respect to umbilicus to anus and limbs. So, if the system says, particular patient having, Pittam, this scale is 1 to 10. Pittam is 4, that is a kind of probability value, and Pitta Badam is 1 and Badam 0. So all the combinations, and means so that the patient can able to change their dietary plan. So this is the ultimate aim of doing this research. As I told, the future plan, yeah, these are all some of the other results. So see here, the whole body symptom is adjusted, that is in right hip, and head to supranostril is burning of eyes. Umbilicus to anus here is jaundice. See, the body is affected majorly by the pitta of 5.7. So accordingly, we come to do the other measures. Okay, so it's in a preliminary stage. So we try to adapt this in the as I told by introducing the semiconductor like the chips, how to make it possible. When and where, always. So, we can extend. This is not the limited one. We can extend this by adding the data set. So here the data set is limited. Then integrate since doctor can analyze easily by holding our hand, our wrist itself. So sensor development is also required to do this research, and that is since everything all the literatures are in Tamil, so it is possible by us to convert it to all the regional languages. Then we can scale and explain. Means since why the patient is affected by wisdom and cover, we can incorporate the explainable AI into this research. Also in the recommendation, ultimately the GenAI plays a major role. So another one is, so I quickly wind up this. Since this is the body type, and we do have a lot of herbs available in nature. So how that herbs will be helpful for curing any particular disease. So that is the ultimate aim. So most doctors only help us to do this research. How do we have it? I mean, this is the overall architecture diagram. They have written a book of 500 medicinal plants in their botanical names as well as the suppose if it is in Kacharina, suppose Vengayamna, in Kerala they call it Hindi. So in different names they used to call. 5 regional languages we have identified, and description of the particular plant. their buds, their stem, their leaves, their medicinal effects of different parts of the body also has been given. So we collected the data and we have converted that into the CSV as a data. And since I don't know, suppose இப்போ தமிழ்ல வந்து லைக் இந்த தலைவலிக்கு வந்து நொச்சி போட்டு நெபுலைசேஷன் பண்றது மாதிரி ஆவி பிடிக்கணும்னு சொல்லுவாங்க. ஸோ அப்போ நொச்சினா வந்து எனக்கு தெரியல, நீங்க எத்தனை பேருக்கு தெரியும்னு சொல்லிட்டு. ஸோ ஐ மீன் இட்ஸ் அவைலபிள். இப்போ ஐடி மெட்ராஸ் ரிசர்ச் பார்க்க போகிற வழியில் எல்லாமே நொச்சி இருக்குது. பட் அதுதான் நொச்சின்றது யாருக்கும் தெரியாது. But when you see a picture in the Google image, ஆனா அதுதான் இதுவாங்கிறது நமக்கு தெரியாது. So அந்த herbs வந்து the ultimate aim here is by giving the input as the nochi in a word or the letter as one of the input. Another one is by giving the input as an image. So both the way is possible. So we have collected the image as well as the data as a data set, and as I already have told, we have to normalize it. So pre-processing, all the pre-processing, since for the text we have to tokenize it, then normalize பண்ணிட்டு data cleaning, all the process has been carried out. Yes, see here, just to say a few inputs like yes, when I give a query medicinal uses of neem tree, pre-processing level, what we have done here is we have converted everything into the small letters. So which has been, then we have to tokenize it. After tokenizing, if we have any correction, that also has been carried out by the fuzzy mapping. So in another like sorry, yeah. So solid input but it automatically connected. And as of now, we have fed only 80 medicinal plants to do this research. So botanical names A and B only we have been carried out. Suppose if it is not available, okay, since it's our system, so in the system Javandi that doesn't show the output for this particular plant. Then, so what we have carried out, we have collected the data, created the data set, all the pre-processing has been carried out. Then we have used the deep learning algorithm to do this research. For the image perspective, it is the data, we have done the machine learning algorithms. So finally, since I have asked the system medicinal users of me, yes. So if we have given the prompt correctly, it is the OpenGPT model only we have used to produce the recommendation, generate the description of the medicinal uses of the particular plant. Yes, so it is possible by produce or by give the text as well as the images in it. So this particular presentation, that is this slide, shows the image as an input. So it will be onion. Onion will be another names in the regional languages. So 5 languages we have chosen, and the medicinal uses with respect to other any parts of the plant. That also has been carried out. Then we have generated the summary, that is the medicinal uses of the particular plant. This is, and another one is by the text. So துளசி வந்து C ல இருக்குது botanical names ல. So we don't have this துளசி as of now. And so this is the aloe vera to the yes. So this is, I mean, எப்படி இந்த ரிசல்ட் வருதுன்னா respect to the confidence score only we are calculating. And here these are all the deep learning algorithms we have used, since our plan is to make it as a mobile app. This mobile net we do here to do this. So this is, I mean, we have the recent extension of mobile net we do also, mobile net also available. So finally, I want to conclude this talk. It is possible by us to integrate our traditional medicine in the AI also. Since people generally allopathy, in allopathy all the ways we are doing the research, but in the traditional medicine also we have to do a lot. So it's a kind of exploring the unexplored. So many recent researches as well as development should be carried out with the traditional tools. If you have any doubt,
So who is the interesting part of
answer. As a researcher, we are doing the research, and the doctors are helping and validating the data.
make this as a solution and understand?
As of now, no.
So this is really
See, if we don't do the European countries or the Western, they collect our data, they make it as a system, and it will be popular for their country instead of. So we have to do the research and we have to develop this as a good system and helpful for our generation. So that is the main motto to do this research. It goes to doctors, their parents also doctors. எல்லாருமே வந்து even in the Siddha industry, in the general Siddha as well as the Varma, what they used to do is அவங்க learn பண்ணிக்குவாங்க. They don't share that information to anybody else. But those two are fortunately my cousin. Uh, so they want to digitize this information. So it should be used by everyone. Since medical admission is through the NEET, North Indians also coming here at MAS, National Institute of Siddha, and they are studying Siddha. So the literature is in Tamil. They don't know Tamil. So ultimately the translation is required first. அப்புறமா நம்ம knowledge வந்து மத்தவங்க எடுத்துட்டு போறதுக்கு முன்னாடி we make it as digital and it should be useful for our generation. That is the main motto to digitizing this thing and doing this research. Thank you for the opportunity.
Small note, ma'am. It's a good topic. It's completely different. So just start off asking you a doubt. So you have mentioned there are several symptoms for several diseases. So how will the algorithm classify it as a particular disease? You have mentioned 33 symptoms for a single disease. So the same symptoms can be for the different disease also. It will be having the same symptoms.
Yes,
so
and overlapping is occurred that already has been addressed by us. When we do the data cleaning as well as the pre-process.
So it is very difficult to identify because headache means there are several diseases that have headache. Right?
Yes.
So how will you classify it?
அது மெயினா வந்து பித்தமால வரதுதான்.
Okay.
So பித்தம் and along with the other symptoms. So பித்தம்ங்கிறது வந்து it's common for most of the thing. It is reflecting in any one of the way with the பித்தம். So அதுல வந்து correlations வந்து இருக்கதா செய்யும்.
Okay.
It is correlated.
So how can we definitely say that it is occurring for a particular disease? Is there a need for an expert to validate this?
Definitely, that's very we along with the doctors doing this research.
Okay.
Without their help, we cannot. It is not at all possible.
yes,
They
doctors have to use AI as a kind of assistance.
Okay.
But it's not going to replace
The doctors. But this is for the medical students also. Since I mean, when they studied this thing, they used to memorize a kind of 4 line poems for particular symptom with respect to the region. They have to memorize those things. தமிழ்ல படிச்சவங்களால வந்து that is possible. இப்போ நார்த் இந்தியால இருந்து இங்க வந்து தமிழ் படிச்சு இந்த 4 line poem வந்து மெமரைஸ் பண்ணிட்டு அனலைசிங் தி symptom in the region is very difficult. So that's why we have started to do this research. அப்போ இந்த மாதிரி வந்து suppose when we say the symptom with respect to the region, if it is a system, just to they type instead their language also, no need to learn Tamil or English. If we produce that as in Hindi, so it definitely will be helpful to analyze the body disease. We are not going to treat. We are not going to recommend any medicine. Pharma again naanga pogala ipo as of now. Just to identify the body type. Vadama, Pittama, Kavama. And we are going to recommend only the food diet. ஓகே, சாப்பாடு வந்து இதை சாப்பிடாத இதை சாப்பிடுன்னு சொல்றது தப்பே கிடையாது. ஓகே, ஏன்னா we have done a lot of research. ஸோ ஃபார்மாக்கு போனாக்கி எங்களோட ப்ராப்ளம் ஸ்டேட்மெண்ட் வந்து no one will accept. இண்டஸ்ட்ரி அந்த மாதிரி இருக்கும். ஸோ we have restrict ourselves to identify the body type by the symptom and the region. Okay.
Very much. For example, if today my mind has come up, in the entire lifetime, we have been having
No, not at all. See, actually, I mean that also a different story. I mean, இது ட்ரெடிஷ்னலா அவங்க அந்த சித்தாஸ் வந்து எப்படி டிஃபைன் பண்ணியிருக்காங்கன்னா, நம்மளோட பாடி ஜென்ரலி மோஸ்ட்லி வாதமா மார்னிங் 6 to 10, then 10 to 2, 2 to 6. ஓகே, வாதம் மேஜரா இருக்கும், தென் பித்தம் மேஜரா இருக்கும், தென் கபம் அப்படிதான் இருக்கணும். So when I produce an input with respect to that time, that analyze the data. Okay, yes sir. நான் இப்போ வந்து எப்பவுமே வந்து ஒரு இதை கொடுக்குறேன்னா, ஐ மீன் அவங்களோட அனாலிசிஸ் அந்த மாதிரி தான் இருக்கு. With respect to the time also that analyze. Sir, that is not at all. See, I want to check myself now. We should do. அதுக்காக நாம ஈவினிங் பண்ணணும், காலையில பண்ணணும், that's not at all possible. Yes. இல்ல அதுதான் accordingly we have to given a threshold to analyze those people. இப்போ இன்னைக்கு கபமா இருக்குதுன்னா I can change my dietary plan. Okay, so next another two after 2 weeks it may be with them also. So நம்ம பாடி அதனால தான் சார் சொன்ன மாதிரி சுகர் அனலைஸ் பண்ற மாதிரி இதே வந்து நம்ம மானிட்டர் பண்ணிட்டே இருந்தாக்கி it will be good. We can balance this.
I think there's a good opportunity to do AI like those stuff.
Yes.
I don't know whether anybody is doing it, but we need to do a research on that and then probably jump to it. Probably, maybe a project for the interns over here. Maybe we can collaborate on this. See how we can, make it happen. AI applied.
Yes.
Yes.
Why should I take 70% capital part? So different parts very different.
No, any person I didn't get you.
You start same thing, it goes for same percent. On another note, because I was like code, usually like so why do you start this? For example, everybody comes to the field, why can't you come to the park and find out there is a diversity based on part. You show your slide. So you show me one part has come out. Other part is showing how to make different parts. And actually different parts got
So
different
the
parts.
symptoms are generally first ஒரு பொறி எப்படி இருக்குன்னா whole body symptom. So the whole body generally வந்து நீங்க I mean இதுதான் சொல்லி as of now doctors ஓட analysis they used to ask ourselves நம்ம என்ன சொல்லுவோம், எனக்கு தலை வலிக்குது, எனக்கு கண் எரிச்சலா இருக்குது, வயிறெல்லாம் ஹீட்டா இருக்கிற மாதிரி we used to say yes. So they are converting that into the symptoms of particular regions. இங்க இந்த பிரச்சனைன்னு சொல்ல மாட்டோம், முட்டி வலிக்குது, இதுதான் நம்ம பேசுறது. So நம்மளோட natural language is converted to the symptoms with respect to the regions. இப்போ லைக் அகத்தியர் வந்து முட்டி வலி நீ போய் எனக்கு ரொம்ப தமிழ்லாம் மெமரைஸ் பண்ண வரல, அதனால I don't want to தப்பா சொல்ல விரும்பல. அவங்க வந்து இப்போ முட்டி வலிக்குதுன்னு ஒருத்தவங்க சொல்லியிருப்பாங்க, இதே இன்னொருத்தவங்க வந்து பாத எரிச்சல் சொல்லியிருப்பாங்க. ஸோ இந்த ரெண்டும் வந்து ஒன்னானா சம்டைம்ஸ் இட் இஸ் நாட். இன்னொரு கோயில் வந்து ரெண்டுமே ஒன்றுன்னு சொல்லியிருப்பாங்க. So the overlapping between the symptoms with respect to the regions also available. So it is addressed and validated by the doctors. Now since we are not the domain expert, இதுக்காக தான் வந்து அந்த ரெண்டு பேரை வச்சுட்டே நாங்கள் இந்த ரிசர்ச்சை ஸ்டார்ட் பண்ணி and they are the collaborators. We have applied this research to DST ARG project professor also. They are the same. She is in AIMS. இன்னும் எங்களோட MOU போடுறாங்க யூனிவர்சிட்டியோட. NIS, we have a few issues as of now, CCRS with the NIS. So they are acting as the collaborators for the project. As of now. The overlapping between the symptoms are available with respect to their disease. இன்னும் நிறைய இதுல தெரிஞ்சுக்கிறோம் சிஸ்டா டாக்டர் மாறினாதான் முடியும்.
Thank you.
Thank you for the opportunity.
So
Yes, sir. Yes, sir.
thank you very much for your insights on the on the research and classification model. So I next invite upon Mr. Karthik, who was done who was created a chatbot all over this team for our company, One Automation. So he's going to talk about what chatbot does in our company itself. Thanks, Karthik.
Yeah.
I welcome Karthik.
Yeah, maybe I would add here few things about the chatbot, whatever we are integrating. See, you all know about chatbot, very famous. But here, what we are trying to do is, the LLM model, whatever recently got introduced, with all these chat GPT and even DeepSeek and all this stuff. We are actually integrated some of the features in a live mode, and even the server is connected there, in the upstairs, and we are directly working with that. And that is what this chatbot is to basically collect the data from the website, whatever we have within our like a reach, objectautomation.com or Stream Academy of Learning, another learning education center we have .com, and then Semicon Dynamics, another website. That based on that, it will give you whatever questions you ask, it will answer you, and that's how we build the system. And similarly, this chatbot can be implemented anywhere. Even for the Techmeet also we can have a chatbot, or with the medicine also we can have a chatbot. Going forward, many areas where we can create. But the important thing is actually how much question it can answer, and what is the percentage the question whatever it answers right, 90% or 99%. Those are all very important. That is based on a number of permutation and combination, especially the data of what you are training. Very important. How much data you are training. Based on the data trained, only it will give you the answer to it. And we need the powerful GPUs sometimes. If the data is large, huge, for doing all the processing and all. So those GPUs also available with us. I just want to tell you that the University of Oregon system, where we have the latest and the greatest, the H100 kind of a system, GPUs from NVIDIA, we have that, and huge, I would say billions parameter also it can process at a time of 5 minutes or 10 minutes. That kind of powerful systems we have in the back end, and the front end we need to do a kind of what do you call JavaScript kind of skills you need to create a nice window and do the evaluation. And then like integration, front end and then the back end, the LLM, the integration, everything, all together. You got to have a kind of a complete the system design knowledge and everything. Then you'll end up developing a chatbot like whatever our team has been working on that too. Okay, so this is a great opportunity also to develop your own chatbot for your own purpose. Multiple areas where we can develop chatbot, and we have very good experiences with that, with the infrastructure to the front end the development. Okay, I think.
So, good evening to everyone. Myself Karthik, working here as a software analyst. So, we have built the AI chat customer queries. It's based on company website. So this is the project overview. So the goal is only ask the query is based on company website. So the scope is it's like you will give any prompt. It's like we are what are the courses we are offering, and internship details. So you will ask in our website. You will generate response very quickly and also efficiently. So this is the scope. So next one is the technology. This is the main technology we are using. Anyone know that? What is the RAG? It's a retrieval augmented generation. Anyone know? So this is the main factor for creating chatbot. So retrieval augmented generation. So next, the key feature is interaction between user and the chatbot. After that, the contents, our responsibility is advanced AI to provide accurate answer and retrieving relevant information. This is the using RAG and retrieving our document using RAG and will generate the response related prompt. So this is also seamless user experience. It is designed use provide smoothing and engaging interaction. This is more scalability. The system can easily handle volume of traffic and the queries. After that, the adaptive design to match the company branding and the user needs for customization. So the both we are working in the front end technology is using HTML and CSS JavaScript. I and Hari is working on the back end, and Anand sir we are working on the front end technology. So front end technology we are using HTML, CSS, JavaScript. It is based basic front end technology to build a responsive, responsive and clean and user friendly chatbot. After that, fits and the AX is communication between chatbot UA and backend process user queries with the page reader. So the backend technology is a fast API. So first of all, we have created one of the chatbot and the testing fast API is application programming interface and the serving request from the front end. After that, I move to Endure, that is final step. So first of all, we are testing the fast API backend technology. So retrieval augmented generation. So retrieval augmented generation is a powerful AI architecture in current world. So it is used for information retrieval from the it's like a website content. It's like HTML or PDF in our website. So HTML and the PDF document will retrieve. So that is the main purpose for that usage. After that, the sentence transformer is one of the most important. So sentence transformer is one of the Python library. It's like used for convert text into it's like a high dimensional vector database. It's like a vector embodies. If sentence will, if example see who is the founder and the CEO is the Zach Addison or Sami. So the who is founder, the founder word will be extracted in website. So that prompt will founder will matching correctly. The response will Addison or Sami is founder of OA. So this is the sentence transformers working in the background. So it is a semantic search and a is called semantic search and a it's like a vector embeddings. So next one is a FAS. It is a Facebook AI similarity search. This is also similarity for it's like a semantic transformers. It's based on a documented user queries. So next one is the model. So we are using open router key. So there are many keys are in that open router key, open API key, Gemini API key. We are tried three key also, but it is the most efficient. Open router is a more efficient for this chatbot. Open router key and model is GPT 3.5 Turbo. It's like we are trying on the Gemini API key also taking and the Gemini API there are three models are there. Gemini 1.5, 1.5 Pro. We are using all the methods, but we are selecting this model because this is a more efficient and faster and cheaper. GPT 3.5 it is a developed by Open API. It is introduced in March 2023. But currently we are ChatGPT using like GPT 4.0, I guess. So this is the current model for ChatGPT. We are using the March 2023 models GPT 3.5 Turbo. So it is generate accurate and contents our response. And also this is also main function PDF number and a beautiful soap. So PDF number is extracting PDF and beautiful soap is extracting HTML documents. We are in the our website have PDF and HTML pages also. So HTML page I will extract. We are using beautiful soap function. PDF extract it is using PDF file. So this is the two function we are using. So this is the front end user interaction. It's like a design in front end. It's like a chat icon, chat window. Once you click the give the prompt, you click the send button. This is the chatbot interaction view. Front end view. This also user input. User can any queries and chatbot respond with accurate and real-time answers. And the user can easily close the chatbot window if it's not needed. So this is the back-end processing flow, test extraction. I already said HTML and PDF converter process beautiful soap and PDF convert to extract useful test for queries and chunking. The chunking is used for sentence transformers. Convert text into high-dimensional vector embeddings used for chunking. See the lot of content in our website. So the words are so many words in our website. So the words are first splitting using chunking. One word is splitting. It's like, for example, internship details. We are offering it's like so many interns of AI, chip design, and the content coding. So there are more offering our complete OA. So that is the word embedding. So split by one by one. After that, all the words are chunky. They give the response in backend. So next is the embedding generation. This is also sentence transformers is used to do vector embeddings of test and semantic understanding. So this is the FIAS Facebook AI semantic search indexing. These embeddings are stored in high performance search and retrieval of RAG. So RAG integration. So this chatbot using RAG to fetch the most relevant test and they will form response using OpenWrite GPT 3.5. Already said GPT 3.5 dashboard we are using. So this is the final step. So we are trying also the Azure hosting. Slightly this is final step for hosting. So we are trying Azure, but uh, trying this also without backend code recruit. We are running in our chatbot in website. So this is the Nzero. So Nzero is a tool that is allowed to like local server to the public network. They are secure tunnel. It is extremely used for locally uh, sharing locally on the hosting web application. So without deploying, we are using Nzero. So our first core we are on server. So Nzero will running 24 hours. So chatbot also running. So without backend moderator, only front end will run the chatbot. So this is the process for Nzero integration. So this is the I already said this is the flow chart for I theoretically explained. This is the flow chart. First load and HTML PDF document in our VS Code. After that, extract test and HTML and PDF test content instruction, test is chunky. And we are using sentence transformer, mini LM L6 V2 model. So there are so many models in sentence transformers. We are selected mini LM L6 V2 model. So this is most efficient model. So because we are using. So store in Facebook AS medicine syntax. After that, user input query. What query will with your preference, we will give any query, we will generate related response. So search top chunks and their percent similarity is the main purpose and build contest from chunks. After that, we are using GPT 3.5 turbo model. After that, like front extremely AI response, friendly helpful. After that, the enjoy will I get after that I integrated with Ensure. I get one of the URL, public URL. That public URL I fetch in the front end code in HTML. Fetching the HTML code, it will run 24%. Okay. So this is the flow chart for our website. So this is the real time example. If you try, if any give try to any query in our website, it will response this way. So do you offer any internship in web development? Yes, we offer both offline and online internship in web development. So this is the real-time example. If you can feel free, you can also try in our website. It's like answer. So this is the screenshot for our website. So So and also we are implemented voice integration, voice integration using test to speech to test. If you only give the test, we are feature it's like it is clear in the laws. Voice integration using NLP, natural language process, test to speech to test. We are that is also we are implementing. So if you need help,
What are the text it is inside the website alone will come in the
there's only come website content. Apart from website content, is not there. The prompt will give only give website content. Apart from you give any general prompt, is not there. So website content is not a website. It's a response.
Instead of going and searching every tab in the website, if I ask anything in the chatbot, that will give the answer.
Anything
That's all.
apart from who is CEO,
Not
who is the
doing
director,
that. So what
apart
are
from-
the courses you are offering?
What are the
And
courses?
what types? So all the details if I ask the chatbot. ஒரு டேப்பா போய் பார்க்காம chatbot கேட்டா எல்லாம் சொல்லிடும்.
if you can feel free, you can say. So any other students?
So as I have said, any questions related to the content available in the website. So you can ask any question, it will fetch the answer from the content within the
Suppose
website.
in the
Any tabs,
institution,
any tabs, any tab.
ஏதாவது ஒரு இன்ஸ்டிடியூஷன்ல இந்த டிபார்ட்மெண்ட் இருக்காங்க
ஆமா, ஆமா.
உள்ள போய் சர்ச் பண்றதுக்கு பதிலா இப்ப ஆஸ்க் சாட்பாட்
You don't need to skim through all of the multiple content so that it will give you what are the same information you want. It will give pinpoints, immediate information. It saves time.
End of searching kind of searching. More than
So thanks Karthik for your great presentation on very call chatbot. So now we go to Kimberly, who will going to talk about Linux. So as Sar said, we have tied up with University of Oregon. So students, most of students are able to access the University of Oregon server for chip design. Chip design involves all steps, fabrication, verification, all those things. It requires large amount of storage, large amount of processing power. So we are accessing the University of Oregon server, and we are doing this. So now we are going to give you a live demo how to access the University of Oregon server and do this FPGA. That thing called FPGA in chip design is going to explain about this. So I made a community.
Yeah, good evening. So today I'm going to talk about the design that what we are developing here. So mainly we are working on two open source projects that has been developed by IBM. So the main thing one is this Megawatt. It is an open source software processor developed by IBM in the year 2008. So it is developed under this Power ISA architecture. That is Power Instruction Architecture by IBM. It has been written in language called VSTL. In software, you have language like Python and Java, similar in the script design, we mainly use three types of languages called Verilog, VHDL system Verilog. So this microwatt has been built under the this language called the VHDL. So it is developed by Anton Blanchett. Here, since the IBM has developed it as an open source open source software process, so you can try to implement it, and we can work with this how this process has been working. We can try to class it in the FPGA that currently in our office we have one FPGA type. FPGA means the field gate programmable memory. It is a kind of a chip, not like an ASIC chip, where we mainly code the main processor. So this chip will work on the processor. Where in this FPGA, it is kind of on board that we will process this software processor before getting into the main chip to test this functionality. We'll use the FPGA board that named the RTK700T FPGA board that we currently work to flash this processor here. Since, as I said, this has been developed under the Power ISA architecture. It is also one of the open source architecture. This architecture has been built by IBM. This Power ISA come from this RISC architecture. That is the reduced instruction set architecture. That is currently now everywhere we are using this architecture. From this RISC architecture, this we are uh, building our own processor or for this laptop thing and also for the phone like Snapdragon. They also mainly today we are in our world that we are using this from the RISC architecture. From the one type of RISC architecture, we come to the architecture that we developed for this microwatt is power ISA architecture. It is a simple kind of thing to get to understand. It's like a five pipeline stages to execute this architecture. That is the fetch, decode, execute, memory, write back. Where the first stage is the fetch. It will fetch the instructions from the memory. Then decode stage. It will decode the what type of instruction that is going to where it gets from the memory. From the input that what type of instruction so that it will decode it and then in the execution stage where it will perform the actual thing that whether the input may be that what type of input is it, whether it is an ALU that is arithmetic logic unit, some of this adding, subtracting like that, or memory, a CAD stick, whether what type of input it is, it will execute in the execution stage. Then the memory access where it will read and write the memory and the write back where it will store the memory, the storage into the register file. It is a simple five stage of architecture. So here to build this, we have to install certain tools that I am not going into deep. That I'll show you that what how we build this processor and how we are flashing it. For that to verify this processor, we use one tool called the GSPL. It is used for simulation purpose. Simulation is a thing that we use it to verify our code. After we need to compile and the things to wait for that. So this microwatt, we use the tool called the GSTL for the simulation purpose, and also we use the cross compile for the Power PC. As now we are going to build the Power PC, this microwatt in our system that we are will try to create one Linux image, one minimal Linux kernel image. We are trying to create it, where that we are going to flash it into the process that we have been developed this open source process. Where inside this we are going to put one Linux into this. For that, we are going to create our own Linux image. To do this all these operations, we will work, make that image to the specified architecture for to work to create it on the micro architecture. So for that, we are going to use this Power PC or this tool set where it will convert that since you are going to run that in your system. Our system is developed this x86 architecture or ARM architecture. We are just giving an additional information to this using this toolchain to build that image or the thing to set up for this Power PC architecture to create like that. For that, we are actually using the toolchain and so there were some of the steps to download these tools and to set up. I not just in this, just these were the things we'll try to download it and to run that. After we install that, this is the main microwatt code that has been available in the GitHub. So this is as I said, it is an open source one. You can download it into your system and you can get to perform it. So while run this, we command it will compile your microwatt this processor. Now what we are going to do is, so we are going to make the software processor to flash it into the hardware. That is your FPGA board. So for that, we need to flash it. We need to have a machine learning understanding code. So we are going to make this whole microwatt thing into a bit file where contains information as zeros and ones. So the bit file we are going to create it, and the bit file we are going to flash it into the main FPGA board. So for that, we are using this fuse SOC tool where we will just everything this will be work under the Linux environment. So everything will be in the command based thing. So we use this fuse SOC thing where we run and build to set the target which code that we are going to build. I mentioned this the target code that we are I'm going to build here. And the size, the memory size just for that. So after I run this command, what it will do is the git load microwatt project. It will now create a big file for the targeted boot. Now you can after it runs test, you can able to view the mega big file. So now what we are going to do is we are going to flash this big file into the board that we are going to use. So after we flash it into the board, FPGA board, now that board will act as a mini processor kind of. It will work as a microprocessor. So after I detect the bit file, I'm just using it in the command open FPGA loader. Using that, I'm going to flash it. So currently here in our office we are having the physical board of this FPGA board, the sorting board, and also as I said, we are also tied up with this University of Oregon, where in this complete setup has been there. So this for this Linux tool, this FPGAs that have some certain FPGA board also available in the server. You can get used to that FPGA board. After some, if you have a file, you can create your own ID there, and you can use the available FPGA boards that has been under this this Icon server. So for that, just given the serial number here, I mentioned it as is the number of FPGA boards that is available. I'm just selecting that one particular board that I'm going to flash it. Since there have been multiple boards available in the server, I'm just been pointing to the specific board here. Uh, you can for that you can use this command to see this available boards that has been in the server. While you run this, you can able to see certain FPGA board that has been available in the server. Like there have been five types of five FPGA board that has been connected to the server currently. You can able to see connect to the particular board using the serial number. So every board has a unique serial number to this. So to flash this file to directly to the specified FPGA board, we can use the specific serial number for that. Then we try to flash it into the FPGA board. So after we flash the now the FPGA board will act as a processor. So now what we are going to do is to test the processor its functionality. Thus we are going to put Linux into this. For that, as we build this microwatt, it is minimal processor, not the complete processor. So here we are going to create our Linux image that supports this microwatt architecture. So for that, we are again going to use this script from the build root where we create our workspace. And here I had mentioned it this make for PC microwatt config where I had configured this to create the build root this under for the PowerPC architecture. Then where I will get one root CPI go. After that, I include the Linux kernel. Then again here also I am mentioning that the target architecture that I am going to generate the ELF image. That is, you all know, right? So if you want to set up your put the OS in your system, that what you will do is so suddenly you will get to download the one Linux image that will be available here. So like Ubuntu 22 like that, you will get to click that. That one image will be downloaded. So now after that you will get to store that into USB. Then you will set up in your system. Then you will have some certain OS that will be installed in your system like that. There it has the Linux image for that available architecture. That is we are using for the Intel and AMD. So to simply use the image to for this microwatt architecture, we are going to build its own image. For that, we are using this Linux kernel that has been available there. That we are giving an instructions to make it for this microwatt architecture. Then afterwards, it will generate one ELF image. So this is the ELF image, this Linux kernel image that has been developed. This image that we will try to flash it into the processor. Already in the board that we have tried to flash the processor. Inside that we are going to add this flash this ELF image. So now then what it will do is it will put Linux into that. Now you can able to get the complete setup where in the processor you have you run an OS into that. So inside that we have put a Linux. You can test the functionality and you can perform multiple operations in the put a Linux also. Yeah, and this is also common to test the where I have mentioned the spot where the ELF is being located. So this I have given this to try to flash it. After while you try to flash this, you can able to view like this type of a console where like this Linux. You will get a window where this total Linux has been popped out. It will say some kind of the window there. You can able to perform the minimum Linux operations there. Suppose if you want to additionally add your Linux feature, if you want to improve its configuration also, you can build. So as I said before, in the creating the image thing, where you can add in the configuration part, so you can go to this in the build root stage where so, yeah, so in the build stage, there are two certain space where you can add some additional configurations to your your Linux that things you can add. Like suppose if you want to add your Python into the Linux also, just you can add it from this build root where you can make it config and you can select the Python that you are going to need, and after you enter that you again have to rebuild the image. Then we can try to come and flash it the image. Then afterwards, when you put that, you can able to view the Python that will be installed in your Linux system. So that's something. So if you want to work with this server, I'm just entering into my Tunistar Python server. So under this microwatt Linux directory, I had installed the three files. It showed I everything in the microwatt folder. I had already run this microwatt browser, and inside this, if you go through that, you can get the file there. Since I had already flashed it, so if you want to open the folder Linux there, we use this command speak where now it will start to run. Then you can able to give the folder Linux there. So here now you can perform the next operations here. You can also add additional information. At this here now we are also trying to implement the ML, try to run the ML inside this Moodle Linux. For that now we are also making this microwatt to add some instructions into this and to optimize this performance. Since it is the minimal kernel Linux, now currently we cannot run this ML thing like the original Linux. So we are trying to add some sets of instructions into this microwatt code. Since it's an open source one, you can also we can try to add this sets of instructions to this, and we can try to optimize it, and we can increase its performance, and we can do this. So this is one set of operations that we are going mainly doing. So this microwatt open source one to build your processor and to run the Linux into this. That is the one thing. The next part is that we cover the physical design, the back end part of the chip design, where we will create our own chip. We'll create a layout that is it is called a GDS layout, graphical design thing, where it will create the final layout. In the front end part, till now we discussed about this front end part, where you will write the code sets of instructions for this to reach the thing will to work this processor inside this microwatt. If we go through, there are some sets of instructions for that. That will be there, and you will try to flash it into the chip. So then, in this physical design, you will cover that. We'll try to make our own chip of this. So for that, we have some certain stages to build this chip. That is from this flow plan to the sign up. What it will do is this in a simple version you want to set is you can create your own chip just from the size to the components that what we are going to add and what we are going to use the IO ports that is to connect this. Every details that will be given in this flow. Then after the last routing stage, it will generate one final details to layout. That is, it's like a this architecture kind of thing where every pins and nets that how it will be, then the components that how it has need to be placed. The details will be contained in the one format, one file called the GDS2 file. That file we will send it to the factory for the fabrication process. what they will do is we'll send this layout and they will make a chip out of it from the layout that we have created. So to make the layout to make it completely, this is the the flow that we are going to develop. That is the first step is the floor planning stage. So what we'll do is in the floor planning stage, we'll create one die area, the core area of the chip. The size of the chip will declare in the floor planning stage, and we will add the I/O ports, the pins that will be necessary to connect your chip to the output or input thing. So we need to have the I/O pins there in the chip, right? So that I/O pins will be placed in the floor planning stage, and the macros, that is the necessary the RAM norm, that is, will be called inside here as a macros. So that thing will be placed under this floor planning stage. Then the next stage is the placement stage, where you will get to place the standard cells. That is, standard cells contain nothing but the logical gates that will be everything will be have certain combination logic gates that will be under this one standard cells. Then the standard cell placements will be done inside this placement stage. Then afterwards the placement stage, you will come into the clock tree step, where you will connect your clock to the respective your registers. As we said, this inside the register, you will store the information. So, like the flip flop. So, from the outside, you will get an input from the clock signal. You will receive it to the register, and it will get an output. So, this the entire process, this clock signal need to be distributed to every register file simultaneously. So it will improve its performance. So, in this clock tree into the step, we'll make it assure that this signal need to be transmitted to the every available things, that is the registers need to be at a time. So to reduce to make it happen, we'll try to optimize it in this clock tree into this step. Then the next is last stage is the routing, where in the routing you have some metal rails that will be flowing through, where that power will be flowing through this rails. From that, the power it will get connected to the required components that, as I mentioned here, standard cells macros. So to give powers to this things, it will get from the power rails. So this connection, this place, this thing need to connect to this components. Everything that will be done under this routing stage. Afterwards, the sign of the final layout will be rendered. Like suppose like this, it will be it's now in the placement stage, where you can see the at the corner the IO ports, and in between this loop that one is the macro. Now in this stage, like this it will be. So mainly this macros and the small things will be standard cells. The store area under surrounded by the area, like this kind of a thing. It's like one a layout. So after we complete this all this flow that I have mentioned here to generate this GST layout, this it will generate you the final layout that will send it to the factory for the fabrication. So currently in industries we are mainly using this tools called the synopsis and cadence for. But now this Open Core Foundation has come up with a tool called the Open Road. It is completely an open source tool where you can perform this PD operations and it is an automated tool also. Just you will not like I explained, the step by step process you get that you will not need to do. If you are a printer developer, I think if you are only need to write a code like that, you understand also. Just from this tool, you can able to build. Just you will write your RTL code and you will PT to this tool. Then you will run the remaining thing. This from this floor planning to this final layout generation. This tool will do it. There you have some ISO scripts into this to make it a full automated thing. Where you will, this tool will generate you the final GST layout of it. That's also available in our University of Oregon. This open source tool also that they have been set up in this inside this Oregon server. You can get into that and you can start with this. If you are interested into this PD physical design, you can go and use this open road tool for this physical design. That's also
Let me add here so that it will be very connected. So, how many of you doing ECE here? Nice. Okay, no. Okay, one student, ECE student. So this is more applicable for ECE, but and also like computer science as well as the electrical student, definitely can collaborate on this. Because we are not just only developing the chip, we are also developing a firmware of the chip, and also we are booting the Linux system, and we are also running the AI application on the Linux system. So everyone need it. It's not just limited to the ECE student. So whatever he showed, like using that similar technology, Open Power Foundation, you mentioned that, right? That is basically IBM's the foundation. 2013 timeframe, IBM inaugurated that along with NVIDIA, Mellanox, like 200 companies. And now the foundation has grown, and there are a lot of the chips and the systems are all coming out from the foundation. And this is one of the chip from the foundation called IBM Power 9. And after this, the Power 10 also came, and now, recently, like I think last few days, IBM is demonstrating the Power 11 system. So this chip, especially being utilized by many banks, including Bank of America. We have a person here who is from Bank of America. She is also going to talk about few things about what she is doing, and the Bank of America is one of the key customers for our power chip too. So we can do a lot of things with this power chip. Like once the Linux gets booted, you can do many things. Whatever like Siddha medicine or IoT or healthcare, anything you can do on that. So this kind of platform we are talking about is really happening, and people can make their own devices and processing, the complete processing. This it costs around like $5,000. This kind of processing. So think about it. If you make million processor, how much money you make, and that's how the future. Like, whatever you do. So very important. You guys, all like we have LIT professor Prabhu here. LIT we have been collaborating very well, and very significantly, they invested money on money with us actually and with IBM. Last I think nearly 8 years we have been with Watson and the chip design. So many things we have been collaborating, and we have relevant. He has been with us for last 8 years, I would say, and Muhammad, huh? Dan is in college. He is also professor there, and he has been collaborating with us for many years too. And definitely, this kind of technology can go to students and faculties and the enterprises to basically develop new things. Okay. So, so you showed the University of server system, everything, right? Because this is an entire ecosystem we're talking about. We're not talking about just hey, don't do this. You need to learn about everything. This is a complete system we're talking about, right? So that your knowledge will grow. And your University of Modeling System has got a cloud, and, Linux things and high performance computing, AI, and chip design. Everything is there. Okay. So even if you want to do higher studies, how many students are there here? Students. Yeah, there are quite a bit. So if you want to do higher studies in US or in Europe, these technologies will help you to fetch the opportunity, even stifle. All those stuff you get it. Because I have seen in my career last 20 plus years, so many students with the technology whatever we have been inculcating, they are adopting and they are going to abroad and they are doing a very good job too. Here, people work here and they are working in Amazon, they are working in top companies like IBM and many companies. Bank of America, we have a VP also there. She was here for nearly 2 years. Not she, but there is another person. And there are so many people be inculcated and basically be enabled and they have been in the industry doing a lot of activities here. Okay. Yeah. Any questions for our team here? We have two set of people order for a full stack next time. He is a full stack developer here, and he has been spending a lot of time on developing the Java code and integration and all this stuff. And that is very important to do it front end to do everything. And then the back end LLM and AI feature. And we have Jagan and Kripal team presented it, and they are working on chip design related stuff more and more. And we have a global team also. He knows that actually. We have a team in Seattle area as well as in San Diego area where they have been collaborating on developing these and we have team in Hyderabad as well as Bangalore. Okay. So, any questions? Oh yeah, mother. Yeah, mother is one of the leader here. Takes care of all the things, and he is a business analytic guy, and he knows the Power BI, SPSS, and a lot of the business related things, and also with the statistics background, very strong background with statistics. Okay. Any questions? So you're from, yeah. We set up a center of excellence in many places. Recently at BIT Beirut, and he's from BIT, that's why I'm trying to ask. And open to our center of excellence. A similar system, whatever we have in University of Oregon, we set up in BIT Beirut under the leadership of Shivananda Raja, the professor. He's a dean there. Any questions? Sure. So, anything you want to add?
Exactly as a student point of view, what they used to take is how they get the
Oh,
internship
faculty
opportunity.
development. I ran faculty development, hundreds of faculty development. I propose something and people go and get the approval also. We can also put together a FDP, in quantum computing, chip design, and AI. All three mixed together with some kind of a newer solution to the technology, with a specific AI. That also we can do. Faculty FDP. And writing proposals also. We can also write proposals like as you said, DST and all, we can work on writing proposal. I'm working with IIT Roper, IIT Roorkee, IIT Madras, Central Universities, and IIT and all on writing proposals. So directly they want input, because I'm actually an infrastructure, guy. Like a lot of infrastructure we have. Not many people have got access to all those infrastructure. So they need more information from you. Quantum computing, like in the QCK, whatever IBM open source did, we are a very good specialization with that too. So we can do a lot of algorithms also with the quantum AI. When I was at IBM, I was an ambassador for quantum AI. Even Chandrababu Naidu, I met long back, related to quantum AI, but now we got really happened, and now, I think. What is the state? I mean, in Andhra Pradesh, there is a place, we are going to have a quantum hub, IBM quantum hub, with the investment of $10 billion from IBM. Okay? Any questions? Come on, it's a technique, it's not just my topic.
In future, there are so many opportunities related to AI.
Yes, of course. AI, semiconductor, and quantum, all three together.
It should not replace our knowledge.
No, I don't think so. Assistance.
Just us.
Assistance.
That was the question anyway.
Yeah, people get scared because they don't want those skills. That's what they do. They don't want to develop skills. See, that's what initially I said. Continuous integration and continuous development need to be. You should not just like now. Yeah, I know that. What is your name? Huh?
Funny.
Yeah, Panimalan from Meenakshi College. Yeah, they are actually Meenakshi College is our loan college to our thing. I just want to tell you that. So she came today and she completed her internship. And I said, good, attend the Techmeet. She said, no, I need to go. I said, it's not that you didn't come for just completing the internship. You should continuously collaborate and learn more and more things, and that is where she's going to grow. She's going to definitely grow, and everyone has to continuously put effort. See, with the 30 years experience, I'm putting effort in. Think about it. And tomorrow I'm going to be somewhere, and tomorrow I'm going to be somewhere. But today, I want to stay here and spend some time learning. And yesterday, where I was in US, in Newark, not in California where I live, where I am living, in Newark, some other place where I was doing something. So that's how you got a passion, and continuously you need to collaborate and make it up. thoroughly things will be on your side. Okay. So coming to US also is not a big deal for me. I will make the things happen also for others if they consider that continuously integrate and develop the skills. It's not you may be in the pipeline. Maybe you should come and talk about down this research in US.
Sure, sure, definitely.
There may be a lot of people who would be interested to learn.
Yes.
We Tamil group is there. Yeah, like a community based.
So as a faculty here, even our question may be how do we set up the center of excellence at our institution with the help of
Yeah. I set up a center of excellence in Anna University degree campus in 2008 with a big server. We were donating the server to Anna University.
what's the condition of it.
Yeah, yeah. So similar way. Yeah. Definitely we can talk about that. Sure.
And one more
Even Professor Bhaskaran was working with me. Bhaskaran, he was
in
working. Yeah, he was during COVID time. It didn't work out very well. We do like that. We want to apply for some big funding, to set up a power center of excellence.
definitely will continue.
Yeah.
And one more thing, what are the other possibilities to collaborate in the academic perspective?
Yeah. Education, enablement, all the courses, anything, whatever we imparted worldwide. The same thing. But the thing is now people have to learn continuously. It's not a one time.
As an educational institution, it is possible.
Yeah. No. Yeah. Faculties also have to learn.
It's our duty to update us.
Yeah. Yeah. Many faculties are not doing
The
that.
duty, it's a responsibility as well.
Yeah. Yeah. You are now. I know you are doing it. You have a passion, and that's why you are here. And there are a lot of people who are not interested. I've been calling maybe not just this crowd. I've been calling every time, like thousands of people. Hey, come on, join. Every time, we'll come out, bring in some new stuff. Okay? So let me know. Anything else, let me know, and let's be in touch. Okay? So let us close our meet, and probably if you want to network, spend some time, talk to people. Maybe you want to say something once since you came all the way here. Akila. Yeah, her name is Akila. She's working in Bank of America.
We've been for the past 3 years. I'm into Linux Linux operations. So I've done my course here in my so actually my account and it's that actually. So I was fallen and now I'm doing Azure as well. Instead of taking, so I joined Azure upgrading myself. So we went actually automation went me a lot actually. We know about this because I'm totally new to this industry. So basically I was in different industry. So I just started to technology and this is the ways where I learned. I got an idea. So once we get an idea one day I can do it. Then after joining the company I completed my Red Hat certification, CSC certification for Linux operation related to my job. So I completed that and this year I'm planning for this Azure. And moreover, I'm going to do OpenShift. As you said, I'm planning for that.
That's good.
Because that's cloud, right? So everywhere the cloud is, the AI is there, but more than I'm interested in the cloud area. So I'm planning for the cloud and doing this OpenShift organization. So I'm starting with AZ 104. Started like 2 weeks back. I started the course with organization. Want to learn and what we do. So we have to be ready when this mix operation. Now they ever talk that this AI is coming, it's cloud, everything. When the staffs who are working like 10 years, they are not they don't know what is going on, what they will everything. Even in my company, they will say about this automation, co-pilot. Now the co-pilot is a big talk in our company. So everybody, so if anything comes, they will reduce the resource. So everybody want to learn and Even in my company, manager has been told we have to be hands-on to know some other anything. If anything is there, we have to be ready to move on to some other job, some other. So we want to learn the emerging technologies. So we should have that rigor, whatever it is. No, almost I think like 37 year old young people, so you should be.
You don't need to tell your age. Yeah. Why do you say that?
No, so my experience is, I have a work experience of 10 years,
You
but
can say
still
experience.
learning, still learning.
Except 30 years. You can say my age.
Still I'm learning what to do. That's what when my son I was telling, he was not going to tuition, I'm telling, today now also I'm going for class and I'm very eager to learn because that's the we have to compete. Industry is like that. We have to compete. People when we go for the mid-year review, we go for the year-end review, they get
If you continuously work like this and represent
that's what.
in
We
your
have to
company,
improve our
no,
communication
let me tell
skills.
you. Let me tell you, you will become a VP very short. Vice President of Bank of America, probably that name. Because I have seen Bobika, who is right now currently here. I have seen her.
Myself coming along with my daughter to learn.
Sure. Yeah, definitely.
So
So,
we have
lot of
to improve
opportunities.
it, not only in technology, we have to improve in volunteering the activities, so many things. When you come to company, you have to be explore everything, you have to volunteer programs, to speak up, you have to join in all the event which is going happening. Then only will we get recognized and we can move into our next position. Okay. If you feel like a down, then we'll not. We'll get salary, we'll get everything. We'll not
And
do
then
that.
one day AI will replace.
That is also everybody is saying. That's what. We have
Good,
to
yeah.
keep on
Thank you.
learning.
Thank you.
Thank you.
Yeah. You are going to champion in the Bank of America.
Let's try my level best.
Yeah. Okay. Well, you want to say something? No. Don't be shy.
Feel good to connect with you, sir. Good to connect with you. It's a proud moment.
Sure. No, we will do more, not just to connect, collaborate, and do something more, innovate. Yeah.
Actually, that the man good about Siddham is no. Lot of government funds are available for.
Get it? No? We're going to apply and get it. And maybe in your college, if they apply, they will get it from a different community. So get that.
Introduction is DST. That itself they will give fund.
Actually, I already have tried. They didn't recommend my proposals. So many things happen in
You
the
can
ESG.
do it with the because of doctor.
Yeah. You have to collaborate with industries and
You only have middle for me, sir. 10 years back, you told about big data, and I studied how to build that alone, sir. Here. So I did a PhD and I completed it and I'm working on it. Now the technology moves to AI.
I still owe you an opportunity to do education in US.
Yes.
I'm working on it. Shweta madam is focusing with you. She came, right? So there is a plan. Yes. Yeah. Shweta madam,
To be honest,
she's all over the town.
10 years back, I was here in some place. While studying, I saw him. He's asking me different questions in technology. I can't able to answer any one. Right now, I'm vice principal of my college. Let's say I finished my PhD in computer science. 10 years back itself, he's asking me 10 questions. I told I don't know. Simply, I will be answering I don't know. After that, slowly I learned something. Still, we need to learn a lot.
That's something.
Okay. So let's collaborate and innovate. Yeah. Now we connected already. Okay. let's move on.